sound on. Thanks a lot for having me. I'm going to try my best to have the same excitement levels as we've just had, but I'm making no promises. Before we get started, just quickly by raise of hands, who has got a good idea about what AI agents is and what it could potentially give to software solutions as a whole? Okay, so quite a few. This is a topic that I'm really excited to talk about today. I think for two reasons. One is, it's just really exciting technology. It's really a fun thing to work with as an engineer. And secondly, it's a field that has seen a tremendous amount of growth over the last 2 years. It is something that really has immense potential in terms of what it could give as a software engineering solution. Sorry, sound guys, if I can just ask this sound to be a little bit lower on this speaker. Thank you. I mean, as software engineers, fundamentally, what do? We build solutions, we solve problems, right? And we've got this toolkit of technologies and tools and frameworks that we use to build these solutions. And AI agents is really something that is an incredible, powerful tool that we can add to this toolkit. So I really think it is something that every engineer should be aware of, and ideally should know a little bit about in terms of what it could add to your toolbox of potential solutions. What you're seeing on the screen is basically an Excel sheet. It's on the left-hand side, a column of company names, and on the right-hand side, a bunch of information points about those companies. So domain, description, pricing plan, case studies about that companies, etc. And this is something that B2B sales teams would typically use when they do company outreach. So you would have a list of companies that you want to sell to, and your sales team would go and fill this information for these different companies, and that would help you to kind of do a more effective outreach. And this is typically something that takes days, sometimes weeks for sales teams to actually compile. And what this actually is a product called Clayagent by a company, Clay AI. And what this does is you give it the left-hand side, you give it the company names, and it then goes and deploys a swarm of agents in the background that actually autonomously goes and does research on each of these information points and fills in your Excel sheet for you, basically populating this information in a matter of seconds or maybe minutes. And this is really just a small example of something that an agent can do for you. It's a change in terms of how we approach what we build and what we can deliver from an Excel sheet that we fill ourselves versus an Excel sheet that really fills itself. And this is really something that I would almost place a bet that every engineer in this room would be able to build if you are curious and willing to learn a little bit more about agents. It's a really powerful tool, and it's really accessible, and it's something that each of us can use in our software solutions. And that is what I'm going to touch on today. So firstly, I'm going to share a little bit about what exactly is an AI agent, so get a bit of a better understanding of what we're dealing with. Secondly, from there, why should we care? What does this bring to us as engineers? And then thirdly, we'll have a quick look at how do we get started if we are curious to explore this area in more detail. Very briefly about myself, my name is Mardu. I'm from South Africa, currently living in Vienna in Austria, where I'm working as a software engineer. My experience is across the stack. I've done everything from mobile, front-end, back-end, data engineering, DevOps. Currently, I'm leading the AI integration team at Prewave, which is a scale-up in Austria. My team specifically use AI and NLP to process about 3 million information articles or news articles a day to extract information for supply chains. First point, what is AI agents? And I think this is important to just define up front. I think we should have an understanding of what is an agent and what is an AI agent, because if we really grasp that fundamentals, we can go into why this is really something that is valuable to us. And first of all, I want to just define agent in the abstract, so not AI agent yet. And in today's world, if we don't know what to do, when we're looking for a definition, we ask ChatGPT. And this is what we get. An agent is a system or entity that interacts with its environment, processes information, and takes action to achieve specific goals. Now, I think this is a very nice definition. It's very concise, captures pretty much the essence, but what I really want you to take from this is the following. An agent is able to interact with its environment. So agent is something that is not just a bystander. It can be in an environment and interact with whatever is around it. It's an active role player. Secondly, it's able to process information on its own. So during these interactions, it takes information and it can then make sense of this information. It can do something with it. And thirdly, it can then, given that sense that it's able to make, it can then take actions. So it's not just a read-only and consuming agent, it's something that can then have a stateful effect on whatever is around it. And these things essentially plays together in order to achieve a specific goal, which is fundamentally what agents are tailored towards. If we put this in a diagram, very simply, we get something like the following. We've got information, environment interaction, information processing and acting, and all of these things play together in order to achieve a specific goal. Now, a nice playful example we can use to kind of put this into a bit more practice is a typical like spy movie or secret agent example. So how does secret agent movies typically play out? It starts with the secret agent being deployed and getting assigned a top secret mission. The secret agent then gets a bunch of tools that he can use, so a spy camera and a phone bug, and can do research. Secondly, he then maybe can draw from a mission brief and personal experience, as well as the information that he gathers in this first step. And from there, he can kind of process what's going on. And then typically later in the movie, there's a bunch of fighting and car chasing and stuff. And this happens over and over again, up until the point where the agent then essentially accomplishes the mission and saves the world. And this is, I think, a nice example of where we actually see an agent in practice. Now, taking this to an AI agent, we could have something like the following. A user input is given as our goal. This AI agent is perhaps able to call some APIs, do some web searching. It relies on some form of AI-based predictions algorithm to process this information. And then it can do some DB updates and text outputs. And this is essentially the agent that we defined in the abstract in a software program or implementation, which relies on some AI-based methodology to process this information or to contribute to what it could do. And this is really not anything new, to be honest. AI has been around since 1950s. We've had these agents around, they've been doing things, but they haven't really caught fire. The thing that I really want to talk about today is specifically AI language agents. And these are agents that leverages large language models as this information processing core of the agent. And we all know what has been happening with large language models the last 2 years. The growth has been exponential. There's incredible power that these things gives us in terms of complexity and flexibility. So agents adopting these large language models is really things that has gotten superpowers to an extent. To go a little bit deeper into what a AI language agent potentially could look like from an architectural perspective, we can see the following. We've got 3 components. We've got perception, which is a component that allows this agent to interact with its environment. Going back to the original definition, it can get inputs and thereby play a role in whatever what's going on around it. Secondly, it's got a brain component, which typically consists of memory, as well as then reasoning and planning, and this is really where the LLM comes in to a large extent. And then lastly, we've got actions, which is essentially tools we give it to perform things within this environment. And this is one example of a component architecture. AI language agents is still a very new field. In terms of academia and practice and definitions and architectures, there's not necessarily that a rigid structure yet. But this, I think, is one way of kind of putting down an actual architecture in terms of how you would go from this abstract definition to a software component, or software components at least, that could enable that. To quickly touch on those three components of our architecture, first one being perception. And perception is really the ability for this software system or agent to receive inputs in various modalities. So it could be text inputs, visual inputs, auditory inputs, digital inputs from sensors, actuators, and the ability to take those inputs and then convert it into what we call brain inputs for this brain component to actually process. So this is one thing we typically see in these agents. Secondly is the brain component, and this consists of two big parts. One is storage and one is decision making. On the storage part, we really want these agents, or rather these agents has the ability to deal with what we could relate to as memory. So understanding the interactions that it had quite recently, remembering things that it spoke about and that it learned. But also the idea of knowledge. So being able to draw from a larger corpus of knowledge, of books perhaps, or an information realm that it operates in. And these two are elements that you could say is essentially a storage component that we bring to it. Now, this different forms of storage, as well as the inputs that we gather, are then things that are taken into consideration for the decision-making component. And this is really where our agents do planning and reasoning. So the ability to take into account all of this information that it's gathering in order to decide, what should I be doing next? How should I be making sense of what's going on? And lastly then is what we call an action space. And this is really the ability or abilities that we give this agent to perform actions within its environment, to interact and act upon whatever is around it. And this is typically by giving it a bunch of what we call tools. So the ability to perhaps execute Python code or talk with the API, search the web, etc. And these three components, tracking back, is pretty much the high-level components within these AI language agents, which allows it to act as these abstract agents, which pursues a goal and does different things in order to reach that goal. Now, this is a topic that we can go into for a lot of depth. I tried to summarize it quite a bit, but I hope you have a better idea now of basically what we mean when we say AI language agent. Now, the next question is, okay, great, but why should we care? Why should we, as engineers, really pay attention to what is going on in this field? And there's a lot of reasons I can mention. I think there's a bunch of good arguments you can make in terms of why this is something that you should be paying attention to. But the one that I really want to highlight is the fact that this is fundamentally a paradigm shift in terms of how we go about creating software services or software solutions, rather. Typically, what we are very much used to when we design and build software solutions is we follow the approach of building a deterministic application. So we've got this business context, we've got this problem space, and we try and understand the rules, and we try and understand the use cases and the user flows that our application should enable. We essentially write, for lack of better explanation, a really big rules engine, a bunch of if-else statements. And that's great because we can test this. We can know this is what our system can do. If we give it A and we give it B, it will respond with C, and the side effects would be D. And that's great. There's a lot of good things about this. But when we go the agentic route, we really follow a principle of a self-orchestrating system. We think about it in the following way. We say, we've got this business problem, we've got this problem space. Let's think about the tools that we should have access to in order to operate within this space. Let's give our agent the ability to use memory, long and short term, and pull from information to supplement these tools. And let's go and give it the principles or the fundamentals that it should know and be aware of in order to solve problems within the space. And then we go and say, but the agent, pretty much, you go and figure out yourself how you get from A to B. So it's not a, we go up front, define all of the paths and program every possible solution. We really go and try and understand the fundamentals and equip it with what it might need in order to operate autonomously within the space to figure out by itself what's the best way to solve it. And this is not necessarily a better versus a worst way. There's always trade-offs in software. But I think what I want to make you aware of is this is a different way of doing things. And with a different way of doing things, there's surely new disadvantages, but there's also new advantages and new things that you unlock in terms of the complexity and the breadth of software solutions that you can develop. Now, there's a lot of strengths we can define and put down, but there's 4 that I briefly want to touch on to try and show you what do we concretely get out of this new paradigm that we follow. The first one is autonomy. So the fact that these agents are able to understand information by itself to quite a high degree of intelligence and also perform actions means that it can really operate autonomously on its own without people interfering or having to contribute to its processing. And this is really incredible in the sense that it allows us to build software solutions that can scale without the human factor in it. A good example of this might be a customer support bot, where let's say it's an insurance claim handling bot, where I come with my claim and I give it my information about what went wrong. The agent can then by itself discern that there's more information needed. It could reach out to me, I give it more information. It can then go, it could pull from the claims processing literature, make a call regarding my claim and what it should be measuring it against, and then initiate the bank transfer. And all of this can be done by the agent itself without a human being involved at all. And we see this, like for example, Klarna, the payment company in Europe. They, I think it was about a year ago, deployed customer support agents, which basically did the job of 700 people. Resolution times dropped from 11 minutes to 2 minutes. The success rate of the calls went up drastically. And this is really, I think, a big testimony of these agents, to be honest, performing better than humans on the front of autonomy. And this is really, I think, a very, very big strength that you get from this different approach. Second one is adaptability. Now, adaptability, I think, it's maybe an easy word to understand. It's a bit more difficult to really articulate accurately. But essentially, it comes down to these agents' ability to handle cases that kind of deviate from the flow that we initially would have preempted. So upon programming time or training time, we kind of have this problem space. And we could potentially see it encountering certain scenarios. But adaptability really enables it to handle cases that is totally unique and that we could not preempt upfront. The third one is I think, actually a really interesting one, and I call it dynamic interfacing. And I almost say you can think of this as a universal API. The fact that these LLMs can really receive inputs in any format and outputs in any format means it can really communicate pretty much with any system without having to be pre-programmed to communicate with it. So you can give an LLM a JSON output, CSV output, HTML output, and it could then go and interpret it, extract the information that it needs without actually caring what the schema is. Same with the outputs. If it needs to speak to an API that requires JSON in a specific schema, it could discover this API while running, read up on the documentation, what schema does it require, output the JSON in that schema, and you can then make a function call to that API. So it's really powerful in terms of being able to interact with different systems out there without being pre-programmed upfront in order to do it. And the last one is actually really interesting and I think super powerful. And that's the ability for it to self-heal and learn. One thing that agents are really good at, or LLMs rather, is really good at, is reflecting at its own outcomes. So, for example, if you would make an API call as an agent to an API, and you get an error back, and it says there's a URL parameter missing. A LLM actually has the ability to understand that, recreate the next URL, add the parameter, and fix its own mistake. So it can really get back feedback when it makes mistakes, correct itself, and thereby pretty much self-heal. And this means that we've got a solution that is much more resilient to failures and could actually attempt much more complex objectives, because it might fail, but that's fine, because it could fix itself. Now, there's, like I said, a lot of advantages that I can mention. Those are 4 of them. And I quickly want to touch on a few examples in practice in order to show you how these strengths really kind of shine in use cases. And there's a lot of agents already being used in practice. Feel free to reach out to me. There's a lot of sources I can point you towards in terms of where these things are being used and people who report on usages. But it's startups to really large corporates. Everyone is pushing out solutions that has never been possible, but only been enabled now by using an agentic approach. So there's really incredible solutions being built in practice. I'm just going to show you 2. There's actually such a long list of incredible solutions that I would have loved to show you, but I'm quickly going to touch on 2 in order to make it a bit more practical. The first one is the AI scientist. And this is a paper that's been published not too long ago, which is essentially a group of researchers who built an agent which is able to do research end-to-end. When I say end-to-end, I mean it starts off by coming up with potential research topics. It then goes and searches on Semantic Scholar to do a novelty check, so checking if this is actually something new. It then goes and scores these ideas and chooses the top idea. It then goes and defines the experiments, writes the code, runs the code, gets the results, and then designs, writes the manuscript, and then reviews itself. So it really is a thing of doing research. It's a very specific type of research. It's a very specific type of output. But still, it's able to perform this whole process end-to-end at a cost of $15 per paper in a matter of minutes, maybe an hour, depending on your compute. And this is definitely a research paper. It's still research, so I think there's things to be taken with grains of salt. But I think it's still an incredible testimony of autonomy that this thing is capable of in terms of delivering what takes us maybe a year or years and a lot more money in a fraction of that time. The second example is a company called TradeStack. And TradeStack built a bot for tradespeople to help them with quotations. So tradespeople, for example, interior designers or painters, if they had to come in and do a new, let's say redo a room, they would come in, they would do measuring of the room, they would check what's in it, they would go back, they would do calculations, they would get, let's say, prices for the paint, they would create this quote, and they would send it back to the client. What TradeStack did is they built a WhatsApp bot where you can send it videos, images, voice notes, text, whatever. It then autonomously gathers all of the information that it needs. It then goes and does the measuring of your rooms. It realizes where this customer is located. It goes and searches the web for paint shops nearby. It pulls the prices, it does the quote, and it sends it back. And it's essentially able to produce a quote in 15 times faster, reducing the effort by 80%. And they were able to build this thing in 6 weeks with one engineer. So this, I think, is pretty impressive, in my opinion, being able to pull this off with one guy in 6 weeks. It's a lot of value that you're adding. It's a really complex solution. Building this with a non-agentic application, I think would have been a substantially different picture. But yeah, I think this perhaps gives you a bit of an idea of how these strengths really plays out in terms of what you could put it to use to. Now, lastly, I quickly want to touch on how do I get started. If this is something that you are curious about, if it's something that you really do want to learn about a bit more, there's a lot of resources out there. These are ones that, for me personally, I think I found quite useful, and I want to share them with you. First one is literature. So there's 3 papers that I would recommend you going and reading. The first is Rise and Potential of Large Language Model-Based Agents. This, I think, is just a good overview of the space. Where is it at the moment? What does academia say? What's kind of the architectural patterns we have behind it? Very nice intro. Secondly is the React paper. This is a very famous paper in the LLM space as well, and it's basically about how do we enable LLMs to reason and act in order to achieve something specific. Very good read, like I said, a very famous one. Lastly, the Koala paper, so Cognitive Architectures for Language Agents. And this is really a framework of using a cognitive architecture to think about how do we approach solving this agentic applications. How do we almost go from something like domain-driven design to now an agentic application? Secondly is a framework called Crew AI. This one I think is really nice to kind of get started without having to go too much in detail into a framework. The course on deeplearning.ai is one that they say it's 1 hour, I think it's like 2 hours, but while you make dinner, like put it on the background, it'll give you a good idea of how to get started, and you can build a multi-agent system pretty quickly to just get a grasp of like how does tools work, how does kind of agent personas work, how does the interaction work. So definitely a good one I would go and check out. And then lastly is LangGraph. LangGraph is from the same company that's got LangChain. This is a bit more of a complex framework. It's quite a deep dive. There's a lot of framework-specific things that you need to learn and pick up. But I would say definitely one of the front runners in terms of what it gives you from how to design agents, and also stuff like managing memory, managing flow, etc. So yeah, I would definitely recommend you to go and check that out. Thank you very much. I hope this was something useful. Please feel free to reach out, and yeah, I would encourage all of you to really go and delve into this topic in a bit more detail. Thank you.
Mardu, I have a very technical question for you.
Okay.
This is level of complexity 100. Are you ready?
Well, let's see.
Who is your favorite James Bond actor?
Yo.
Told you, it's hard. Some nerdy stuff here. And careful, you might make enemies.
I think I'm gonna get this wrong. I don't know their names actually.
But
the one that I think he was the actor like 10 years ago, like the really famous one.
Okay.
They're all probably famous. But
I'm sorry, just dump this very techie question on you. I forgive you. And on Telegram, we have a bunch of questions from this guy. Phenomenal question from this guy, Igor Putina. He's very good looking too. Look at him, he's a good guy. So let's see. He has a lot of good questions. Which one do you want to do first? What capabilities do AI agents currently lack that, if achieved, would be a game changer for you?
Sure, that's a good question, because there's a lot of technical components you could, I think, reason about. There's more kind of intellectual components. I would say the ability to handle video inputs really well. Video is a modality that in LLMs is definitely, I think, getting good ground. But if you have an agent that is able to really respond to video inputs, different video inputs, you can do an extremely live, reactive thing with it, which I think could be very, very powerful, and I don't think it's too far. Claude has released a thing quite recently where Claude can actually control your computer using video as an input, which I think is quite a bit of a game changer. So that's something that I would be excited about.
Nice. Well, this wonderful Igor Putina is giving you a lot of good questions, so maybe you should connect in the hallway. There's another question from someone else. How do these real-life applications deal with AI hallucinations?
Yeah, that is a very, very good question. I think hallucinations is, that's one of the big elephants in the room. It's something that we have to deal with, and there's different approaches. There's RAG, for example, is an approach where you try and really scope the information that your LLM is dealing with as narrowly as possible. There's things like reflection, for example, so letting an LLM reflect on the answer that it just gave in order to really verify that it is true. So there's different techniques. There's reasoning, for example, the model, the Strawberry, or I think it's O1 that OpenAI released quite recently, is a model that doesn't just answer automatically. It takes an approach of reasoning through this answer before it actually produces the answer, which is another mechanism. So there's different ways, different routes you can follow, and there's really good research being done on this because this is essentially one of the big issues. But it's also limitation. At the end of the day, a LLM is a probabilistic answer. It's not deterministic. So it's something that is always going to be there. There's ways of dealing with it, but it's still going to be, at the end of the day, a probability of your answer. Yeah.